G'day guys, still going along working on these GPZ-7000s, and I've changed the oscilloscope screen to green. It might be actually easier to look at, and I've got the reference cursors as white. And I think, remember, we started off with a system noise generated from the detector power supplies on the input of the receive module, and it was, I think it started off at about 2.12 millivolts. Then I did some shielding and I got it down to 1.87, and I did a bit more work and I got it lower again. I can't remember what even the numbers are now. They're in the other videos anyway. It's too much numbers to remember. But now, finally, after all the hard work on this one, which I spent hours and hours and hours, I've got it down to 0.68 millivolts. And you can see on the bottom trace there, between the white cursors, actually I can, because I'm running this in high res mode, I can zoom in from behind. If you can see there's a few noise spikes jumping up. That's 50 hertz. And basically I'm not worried about that. I was worried about getting the actual high bandwidth internally generated noise down. So if you have a look at that there, that's 50 microseconds at 2 millivolts per division, and the cursors are sitting at 0.68. So it's as low as I can get it, and yeah, it was a hard job doing that. It was very, very difficult and fiddly and time consuming, but it is there. Now, what I suspected when I dropped the noise floor, I thought that any 50 hertz, I'm trying to run a detector in a room full of electrical equipment, is yeah, well, I don't even know what you want to call that, fool's errand. You know, there's no way of really cancelling out the noise. You know, these things, you've got dongles on them, and you know, if you do something with the coil and you haven't got the dongle in, you know, it won't fire up. And there's a few interesting things I found with the dongle too on the coil. I think I might, I'm not saying this 100%, but I think I might have a way of defeating the dongle, right? Oh, that'll upset people, but hey, it's education, isn't it? And it's my opinion and it's education. So yeah, at the end of the day, you might be able to do something about that. I'm not going to say what it is, because leave every other Tom, Dick and Harry jumping all over it and trying to offer it and blow everyone's detectors up. So I'm not going to say what that is, but anyway, that's our noise issue taken care of. That little spike there behind the transmit pulse, that is, you know, not in the receive window as far as I can tell, so I'm not even worried about that. And remember beforehand, it was God, it was about maybe, what would it be? Probably about 5 or 6 times the level of what it is now, and it had a negative component that's gone. So yeah, that's a lot of hard work on the detector. I'll just zoom this back out so you can see the poor old detector there working away. And what I've done, I've got this on a gain of 1 at the moment, as you can see on there. Whoops, I don't want to do that. Please go in. Yeah, she's on a gain of 1. I've got the audio on 2. I haven't even done a, I should have done a noise cancel scan too. I haven't done that, so yeah, it's in high yield, and you know, who's heard that blip go through? Then that's usually someone switching on a light switch in the house, so you'll get that. But to get this operating to a level which I think is pretty good, you want to see I've got the coil dressed up rather nicely. That's the poor coil. I've got it surrounded by conductive copper and some silver mesh, and that's not going to do anything to the magnetic fields that are getting into the coil, but it's going to probably knock out some of the electric fields with a bit of luck. Even on the detector, I had to go and use nickel-based materials for magnetic shielding. Yeah, I could use all sorts of copper or aluminium or anything, and this has no effect on magnetic fields. It will just punch straight through it. So you need something with very high permeability, and yeah, and you got to do a two-stage approach to it, which seems to work. You can't just go and block magnetic fields. You've got to, what it does, the magnetic materials bend the magnetic path along the grain of the material you're using, and you've got to use specialized um, metals or nickel-based products. And yeah, it has to have a ground path, and usually that can circumvent a lot of noise. Especially if you try to do electric fields with it as well, you can look at doing that and combine it with the magnetic shielding, and that's what you got. That's what a combination of it does on the oscilloscope there. So that's it. And just to prove a point, there is a coil there. That's just moving the copper on top of the coil. And in my pocket, I rescued the 9-volt ever-ready battery, which is that one. That's one I used for the test the other day. Anyone can get one of these. They're worldwide standard test target. You know, I can't use gold nuggets. You'll never be able to get a gold nugget that has the same effect, or rings or anything. So batteries made by a company that has worldwide distributorship everywhere is the way to go. That's my 2 cents worth. And it's a thin plated, probably nickel plated or tin plated steel can, and that's all it's picking up. But it's the size we're looking at. If that was gold, it would bloody sound the same. So no big deal. Okay, so I don't know. Oh, I can't get behind the camera, but if I go across this, I don't know if it's high enough to see it, but I'll go up there. It's probably aiming at me a bit. I'm doing pretty wide swings now because I'm getting up a bit. Still getting it. I don't know if you'll be able to hear that. I've got the microphone stuck on me. Hang on, I'll unclip the microphone. I'll stick it over near the speaker. There you go. Won't hear me now. Here we go. Still getting it. Cuts out about there. I'll line that up with the box when I stand up, so I get my hand aiming at that box. Now I brought this piece of wood in that we were using for measurements out in the field. I just got to get onto the on a gain of 1, right? Just by getting the noise out, that's where we're hitting around that line there. So the standard detector, this is out in the field too when I did this, remember? So this detector's doing really well with the amount of noise, and also putting conductive materials over the coil I hope you can hear me because I'm sort of aiming my voice over there at the microphone. It's probably getting drowned out by the speaker. Yeah, the old WM12, whatever it's called. I'll put this, dear me. There we go. I got the microphone back on me. But yeah, out in the field, I'll turn this around so I'll see what I'm pointing at. Otherwise, I'll shut that up too. Whoops. There you go. We're looking at the sky. Okay, I'll turn that off. I've got to grab that before the phone falls out again, which it's going to. Push it back in, and I've got to lock this. Okay. I'm going to get back a bit and pull this over. Okay, where was I? Okay, on this gadget here. You should be able to see the markings. These are the markings I did out in the field, out at Sparrow Ground. And there was the 4 gram simulated nugget, it's a particular grade of aluminium. It's got additives in it, alloys, and it gives it a similar conductivity to gold. But no gold's shaped like a cut-off metal rod. But these are repeatable objects. That's all I wanted to do. If you start using different nuggets, it makes no sense at all. No one can reproduce it. You just can't do it. Non-modified 6, and then we've got okay, got what's that there? I think it modified 6 is here. I don't know what I've got. NM4 there. It's impossible. So basically, we're getting out in the field. This is the same test, by the way. I'm doing in here. That's what I was doing out in the field, and yeah, non-modified 4, modified 4 is that distance there. Non-modified 6 gram simulated target to there. That's probably meant to say something else. I don't even know what that looks like. I scratched a 4 there. Maybe I wasn't in my right mind doing that. Then we got this doesn't make any sense. I've written that's definitely not, that doesn't make any sense at all. What have I done? Non-modified 6, modified 6. These ones here make sense, right? Except for that NM4. I don't know what I was doing there. And crazy. Don't know what I was doing. I have to go back and look at the videos. Anyone can go back and have a look at the video, and I would have marked that on the video for some reason. Don't know. Oh, hang on, I know what it was. I put the gain up to 16. Remember, these ones are all the gain on 1, and then I put the gain up at 16, and this is where it ran at, I think, from memory. But I've only done like 4 at 16 was on that modified 6 line, and that would have been a gain at 1. If you don't write it down, you're going to get confused. But the main ones here I'm more interested in here was the 9-volt battery, non-modified, was there. Okay. And modified 9-volt, that means, I think it's meant to be modified 9, was here by the look of it. But now I'm getting it up here, modified battery 9. Well, I remember this was done at a gain of 16. Now I'm getting the same thing here on a gain of 1 in noise, in a noisy room. I should have written everything down properly in a notepad. Usually I have my helper, but my helper was feeling a little bit sick. So yeah, that's what that was. That was a gain of 16. Well, I can turn this up to 16 and reprove it. Be a bit difficult in this room though. But this will affect it too. This will affect our depth. I'll show you the difference. I'll just move this over here. And I'm just going to tighten this up to the right level so it doesn't fall off. Okay, so we'll get the detector there. I have to put the noise maker back on. Okay, and I'll get this one here. As you can see, it's on 1. Let's go whack it right up to 16. Oh, this is going to be terrible. It's going to make a lot of noise. Okay. Gain of 16 in the room, but I've got the battery in my pocket and I'm walking near the coil. Okay, so that's gain of 16. That's really asking for a hell of a lot. Okay, let's get this up. That's probably enough angle for you. Let's see how it booms. Okay. Okay, I'll try and get this on the. That's the battery in my hand doing all that. Okay, let's see how we go. I think what's happening is the piece of wood I've got is moving this material and making it howl. If any movement here, it'll go crazy. Like if I just touch that material on top, the conductive mesh, that's what's going to happen. So I don't know how I'm going to do this, keeping it still. I'll try. Come on. I'm moving it. I'll see if I can just do it quick. I don't know. No, I'm moving it. It's upsetting the detector. Hang on. What I'm going to do, I'm going to stand here, look straight ahead, and there's a bottle on there, and that lines up with the tip of the bottle. So I'll get rid of that, so I don't move the mesh. Even just air racing near it will upset it, like that. Yeah, so just any slight movement is going to make it scream. Now, yep, I'm over the top of the bottle. Still going. Running out about there somewhere. Well, not really. I'm probably not over the middle of the coil. It's way above anyway. It's far better than what I was getting out in the field. And I've got this thing really dumbed down. Now, I'll show you what happens if I take this off. Get ready for it. Okay, and I'm just going to drop the bottom bit off the shielding off. Just going to pick up my belt. Okay. There you go, inside the room. Now, the noise has come up massively. You can't help that. Because it's not meant to be operated inside a room full of electronic equipment. But I'll go over with the battery anyway. Here we go again. There's too much noise to get any real sense out of it. But even dumbing the whole system down with that mesh gave actually better depth. Anyway, the poor old detector's having a hernia because I've done that to it. And if you're interested, I'll just give it a I'll just get the gain down because that 16 is way too high. No, I'm in noise cancel. Bloody hell. I'll give it a noise cancel. You can have a listen to all the peaks and troughs and you get an idea of the amount of noise in this room. Yeah. I remember when it gets towards the end there, it starts screaming like crazy. So it must be where all the harmonics of AC lie or something. There it goes. A little bit quieter, not much, didn't make much difference. But, you know, running a detector inside your workshop on a gain of 16 is a mad hatter's exercise, isn't it? Yeah. I mean, that's just stupid of me. I'll put it on 2. There we go. That's a gain of 2. That's it's doing all right, and picking up that target that high. Basically, the coil dumbed down. That will dumb it down massively, throwing shielding material over it. But I tell you what. Oh, do I put this out there? Well, hey, the detector still work with that shielding mesh around the coil. Maybe in a high noise environment, you can build something up and put mesh around your coil, and it might still work and cut out a lot of electrical interference. Now we're going to see copper mesh coils turn up everywhere now, won't we? It wouldn't surprise me. So that's where we are with the shielding. Like I said, get back to basics, fix up any issue that's going to cause noise in one of these detectors, and it's nicely shielded. The module has been shielded, the inductors have been shielded, some of the other circuitry where some big ceramic capacitors have been shielded as well, and that's come up really well, actually. I am impressed. Oh, there we are. And even I'll put it on a gain of 2. How far can we get this battery gadget? I'll try again. We'll see how we go. Try that angle. I'll put the battery over here. So here's our battery on a gain of 2. Now I'll put the microphone over near the speaker just in case you can't hear it, but I suppose you can. Nearly fell out of my hand. About where it was before on a game of 1. There's hardly anything in it. So, whoa, dear me. Camera's going for a 6 again. So, there we go. I'll put it back on 1. Yeah, noise kills the performance of these detectors. I mean, I'm talking terrestrial noise. So, out in the goldfield, this would be an absolute ripper of a unit. It should run really, really, really quiet, and you know, be able to get the targets that are on the threshold of hearing. Yeah. So that's that with this gadget here. Now I'll just turn this off because it can be a bit straining on the ears listening to it. And put this microphone back on. Now over here, now I'll turn this around. Oh dear me, there's a big reach. Okay, now I'm going to spin this around. Like one of my good customers has sent me that gadget. So we can have a go at that and we'll do some discoveries. I've got a feeling it might have the same module as a 7000 in it, the same receive module. Let me think of the operation of the detector for a minute in my head, how it works, and I think it might be the same. I really do. I think the functionality would be the same. I can't see any differences. I've got the actual model number of that module. Some on one of the websites, someone pulled one off a board, and you can see the actual 5082 something or other. I can't remember, but the actual model number of it's there. I'm not sure if it lines up with its barcode. I'll have to compare on this one and see. But I just want to get these 7000s done and cleaned up, and then we can start on this thing. And you know, if I've still got the 7000s, I think people probably, it's raining at the moment, so I don't know if anyone really wants to go out. But if people want to get their detectors and go out and do some field tests, well, you know, so be it. But it'd be interesting to run the two side by side. And I could actually run one of my modified 45s or the 5000. Well, actually, it's not a modified 5000, it's a standard 5000. I've got two standard 45s. Sorry, try again. I've got a standard 45 and a standard 5000. And modified 45s, modified 3000s and 3500s and all that stuff. And yeah, we can do some comparisons with this and just see how good this thing is. Now, a lot of people tell me that the 6000 is noisy, right? Noisy is the word. But there's a lot of interesting things I get told. Now, let's all just say this is hearsay, right? It's not me saying it, it's hearsay, right? It's not even my opinion, it's hearsay. It's what other prospectors have told me. But I have used this and I thought it was noisy. That is my opinion. But the people that use these tell me they're noisy, and that could be just because the sensitivity is cranked right up on it to get the small gold. You know, if you get a dumbed down quiet detector, it's not going to do anything on small, or it's going to get small gold, but it's not going to be as punchy as if it was, a little bit hotted up a little bit, we should say. So it'd be interesting to work out how much gain they're running on this detector in its circuitry, as much as I could find out. All the old ones, the input stages are all set at uh, I say 47 because that's the ratio of resistors, but you've got to add one, so it's 48. They're all set at 48 times input sensitivity. This one here, the module sealed, you can't see the component value, so you can't mathematically work it out. But I can mathematically work it out by injecting a steady state signal and measuring it on the output where the module feeds into the rest of the circuit. I haven't actually done that. I should do that, and then I can see what the gain is on that part of the circuit anyway. And yeah, do the same on this thing. I get it out of the box and yeah, get stuck into it. I don't want too many detectors in bits at the moment. I've got some repairs that have been dropped in. Yeah, there's something over there. What's that? 5000 and 2200 sitting over there somewhere. Where are they? There they are. Yeah, they just got pushed through the door at me. So I've got to do those and get those out of the way. Dave's at the other place looking after upgrades on the GPXs and GPs and whatever else comes in that direction. So it's good actually. He can do that because it's freed me up to get into the nitty-gritty of the detectors and see how we can improve them. If I was just upgrading them all day, I'd get nothing done. It would just be, business as usual. There'd be no modified 6000s. There'd be no, modified 7000s. They'd all just be as they came out. Okay, I got some gossip for you. Right, I got some gossip, and this is hearsay. We'll say it's hearsay, but I have a little birdie tell me, right, that Minelab are bringing out the heavy 7000 in the body of this. Right? I don't know if it's true. Well, when I said the body of this, I mean the body of this thing. So coming out sometime, meant to be later this year, there will be. Birdie says, I don't know for sure. Might be complete utter lies. It might be totally untrue, but that morphed into a 7000. Okay, so I don't know how that goes. Probably still has to have a big heavy coil on it, and if it's got a little light box like that, it's going to be really out of balance, isn't it? It's going to really bend your arm down. I don't know, but we'll see what happens. We'll see if something like that comes out. I didn't even mention the company that was bringing that out. I wonder who that could be. Leave that to your imagination. So that's what I've heard on the grapevine. And I can tell you some other things too. I was trying to get hold of an axiom to test. And I spoke to some people that have used it. And I spoke to someone who is an ex-Minelab detector tester from years ago. And he tried the axiom. And if anyone knows the Maryborough test site, where the targets are buried in the ground, the axiom could only get one target out of all the targets there. So that's just what I was told. I mean, you can take that as hearsay as well. But I can't. They don't sell Minelab detectors, so I can't believe they're telling me fibs. There's no benefit to them. I always look at the benefit ratio in all this stuff. If you're selling Minelab detectors, you're going to say they're fantastic, aren't you? You're selling a Garrett, you're going to say it's fantastic. I don't sell any. I do mods, and the mods are fantastic. You get what I mean? So, it's vested interests on all this stuff. That's what I heard, and yeah, but so probably I'm a little bit not that much interested in the axiom now, to tell the truth. But someone can get one and prove it different, and I'll say it different if you can prove it different. But that's what I was told. They said it's a beautiful, quiet machine to use, and it just didn't have that punchy performance. So that would scare off a lot of prospectors, not having the performance. So anyway, that's a bit of a waffle. That's all I've heard. Seen some nice pictures of gold. Haven't actually seen any physical gold. No one's brought any in lately to say, look at this. So people just email me the pictures. I got stacks of pictures of gold. God, the guys up in Queensland, my God, do they get some gold? They really do. That area up there around the Palmer River, oh dear. Yeah, somewhere up that way there, it just must bloody be loaded. You know, to do it absolutely full time and make a good living out of it. They're up there. Well, a lot of them are using the modified 4500s up there and doing really, really well. And I think some modified 5000s as well. But I haven't heard of anybody using the newer detectors, except the fellow who sent me this. I'm pretty sure he's got my modified detectors, and he's got this, so he'll be using the modified detectors while this is here. I'm not going to say any names, just in case, but yeah, thank you, Mr. Beep Beep, who sent this to us out of the goodness of his heart, so we can have a play and see what we can do to it to get it going better. So that's that. We're up to date. It's going to be raining for a few days here now, so I'm locked in. I can't go out and do any field testing. Every time I want to do field testing, something happens with the weather. It's unbelievable. And if I had a nice sunny day, I'd have something else to do. It'd have to be, something in the way of domestics or, emergency fix someone's detector job or something of that nature. Something always crops up, so it's very hard to plan. Um, Anyway, it's just gone past 6 o'clock in the evening here. That's called dinner time for me. So, yeah, I'll just go back on the oscilloscope there. You can see the center line. I'll just zoom in for you. Right. I know a lot of people don't watch these videos to the end. They probably get bored and, get the gist of it, flick through and go, oh, yeah, blah, blah. He's on about that again. But if you have a look there, that's the detector off. And if you can see the baseline noise, right? It's sitting smack in where those horizontal cursors are, right? So I've got all the noise out of it. As far as I can tell, there's no noise getting on the input stage anymore. So I'm very, very happy. The owner of the detectors are going to be very, very happy as well, because I think it's going to make a difference. I really should delve into the way things happen in these detectors. I just haven't had the time to really analyze the board and see what goes where. But this detector here, it it could be a little bit different than the older versions. That everything signal-wise is being done in the inside a high-speed ADC, and I know there's one in there, but I've looked at the old ones had 8 or 12-bit ADCs. I mean, you're not going to use that for signal recovery. It's too lumpy. You just have too much voltage steps. But this one here might have 24-bit or 32 or something in there. It can look down to very, very low levels, and I just want to see that if by dropping all the noise out of the system, there might be a couple of more levels that the ADC can pick up on, and if it can, it will greatly increase the audibility of gold targets. But that has to be proved, right? All this at the moment is speculation because I don't know. Like I say, if I designed that, I'd know. I didn't, so I don't. And that's the way it is. It's a damn complicated detector. It's got a lot of bits on it. There's parts on both sides of the two circuit boards because it's a sandwich. I think I'm pointing at it. Maybe I'm not because I'm not looking at what I'm doing here. Here we go. Yeah. Whoops. I say there's two circuit boards, one here, one there, and both are chocker full of parts on this side and the other side and that side and the other side. So it's multi-layer boards and it's very, very, very complex. There it is. Oh, dear me. Anyway, I'm going to go and have some dinner. I hope that was informative and of use to somebody. That's what I do this for. I mean, there's no money in doing this. God, I think all the videos I put up, I think I earned $12 or something. So there's no money in it. And it doesn't even cover petrol costs going around doing tests. So, yeah, if you enjoy it and like it, you know, what do they say? Everyone says, oh, give it a thumbs up and subscribe to it. Well, subscribe to the channel. So when I find out some more gossip or hearsay, should I say, that I can let people know about it because you've got to remember I deal with, geez, I don't know. I've dealt with thousands and thousands of prospectors over the years, right? And some of them are in very, very interesting niche positions in various places. So if anything's coming out, I usually get the wind of it pretty quick. I got the wind of the 6000 coming out about 5 months before it did, and yeah, and I was told it was going to be a noisy detector. Funny about that. But all these manufacturers, they can't keep it all buttoned up. I mean, God, it's not the Secrets Act. People will talk and they'll tell their mates, and their mates will pass it on, and all the rest. So news travels. And anyway, I'm starving. I'm going to have dinner. Catches.